we will be discussing arrays, which is basically my introduction to data structures, because I see an array as the most simple data structure that we can kind of delve into without getting too advanced. And I really want to introduce these arrays because you can use for loops and while loops as a way of populating these arrays, and we'll get into that probably at the end of this tutorial. But to start off with, what is an array? Well, an array is basically, the best way I can explain it is a list. So the way I was taught was, think about when you go to the grocery store. Now let's do this together. So we're going to declare an array. We're going to call it string. We're going to make an array of strings, okay? String, and we're going to call it grocery list, okay? This is our grocery list, and this is how I want you to think of an array, because it will give you a really good visualization. So we're going to the grocery store, and we need to buy several things. We need to buy eggs, we need to buy milk, we need to buy bread. So we need to put all these things on a list. Well, to do that, we need to know how many items are going to be on our list, first of all, with an array. And to do that, you put two brackets like this. Not curly brackets, but straight brackets. And inside here, we put a constant value. Variables are not allowed on the inside of these brackets during the declaration of an array, and that is very important to remember. So you have to know how many items you are going to populate your array with when you start. That being said, let's go ahead and assume we're going to have only 3 items on our list. Okay, so we're going to put the value 3 here. Now, the next part is to put these items in our list. So you write equals and then curly brackets. And inside these curly brackets is where we write the items on our list. Now obviously we declared this grocery list as a string data type, which means we have to put string elements inside this array. So the first element is going to be eggs. We're going to say we want eggs, okay? And then you separate each element with a comma. We'll say we need milk, and then we'll say we need bread. And then end the declaration with a semicolon. So this right here is your first declaration of an array in C++. And it's fairly simple. You just have to remember that you need to put the constant number of items right here in the brackets, and then you declare each item, each element in the array, so to speak, in the curly brackets over here. Now, you may be thinking, when would I use an array? Well, you're going to use it all the time. Well, we're going to go into that later. But before we do that, I want to discuss this value right here, this 3. Now, though we wrote a 3 right here, and we can't put variables, so for instance, if we wrote int index equals 3, we are not allowed to put index right here during our declaration. And I believe code blocks sometimes lets you get away with it, but actually it doesn't. See, I just tried to run it and I got an error, and that's why, because we put a variable here. You're not allowed to put a variable there. However, I want to go ahead and, while we're on this topic, discuss constants with you. And a constant is different from a variable in that it never changes, meaning all you have to do is add the constant keyword, which is C-O-N-S-T, const int index 3. So now if we run this, index becomes a constant value and the program runs. Now keep in mind, when you add const right here, you are not allowed to change index later in the value. So if I try to say index equals to 2 all of a sudden, or index plus plus, I will all of a sudden get an error, because you are not allowed to change values that have the const keyword in it, because it's constant. It's not supposed to change throughout your program. So I just want you to keep that in mind. The other thing with constants I want you to keep in mind is that it's often a convention to make constants in all capital letters in C++. so that when you look through the program, you automatically know what's a constant and what isn't. And so this is how you would probably see it in most C++ programs. And though index probably isn't a really good name, you would probably want to say something like size. Size is probably a better word for the array constant. And that's usually how you'll see it in C++ programs when you're talking about arrays. Now, I do want to go into, we discussed for loops last time in our last tutorial, and I want to go ahead and dive into how we're going to use for loops and arrays together, and that's why I made arrays as our next tutorial after for loops, so that it would be fresh on your mind and you can see exactly how we're going to use it. So let me go ahead and show you that now. We're going to make a for loop, okay, and in this for loop we're going to say integer index equals to 0, and then we're going to say index less than size index plus plus. Now think about this for a minute. We're declaring a new variable called index and we're setting it equal to 0. Then we're saying index, this is our condition, we want to do this for loop while index is less than size, and size we set to 3, which is also the size of our string array, and then we're incrementing index by 1 each time we run through this for loop. So this for loop, if we ran it, we'll just see out index real quick so you can see it should only run 3 times, and if we run it, that's exactly what you'll see. 0, 1, 2, the 3 times, and remember index starts at 0. Now when you look at arrays, this is a very important thing to know, because if you don't understand this concept, arrays will get very confusing, and that is to access an array. So let's go ahead and access grocery list. We're going to say output grocery list, and then you put brackets, okay, indel, and inside these brackets you put the number that you want to output. So that being said, let's go ahead and say we want to output eggs. No, let's say we want to output milk, okay? So if we want to output milk, you would think you would enter 2 here, right? Well, that's wrong, because the thing with computers is, and arrays especially, is they start counting at 0. So if you wanted to output the word milk, you would have to say grocery list and then put 1 in the brackets, because this is index 0, this is index 1, and this is index 2. Which is why oftentimes in for loops you're going to see them start at 0, because in a for loop oftentimes you use arrays or even vectors and they all start counting at 0, which is why you will always see most of the time in your programming career these for loops start with a variable that is initialized at 0. So that being said, we can actually put index in this box to print out 0. The next time it'll count through will be 1. The next time it'll be 2. So it'll print out eggs, milk, and then bread. Now going back to a topic we discussed at the beginning, we said that you could only have constants in these brackets, and right here we have a variable. Well, the constant rule only applies when you're initializing the list. When you are actually accessing the array, you can use variables, as we are right here. So let's go ahead and run this program. And you'll see we get eggs, milk, and bread. It prints out the whole list for us. So as you can see, this is a very practical example of using a for loop to iterate through a string array, which we declared as a grocery list. Now, in earlier sections, we talked about just basic console output, and I want to stress to you to not get too concerned about file output, because it's actually a lot more simple than it's going to seem at first. It's going to be a lot of new stuff, but if you just look at it and practice it, you will see how much more simple it actually is than it's going to first appear. That being said, the first thing we have to do when dealing with file output is include a new library. So we've been using this #include IO stream, which stands for input output stream, And we still need this library for our program to work, but we need to add a new one. And to do that, we're going to say pound include, and the new library that we're using is called fstream, which stands for file stream. So you have input output stream, and now we have file stream. Okay, so the next thing we are going to do is declare an output stream file, so to speak, an output stream file that we are going to use. And to do that, we say OF stream, which stands for output file stream, and then you give the output file stream a name, and we're just going to call it output file. Okay, now output file, what you want to do is add parentheses and put a semicolon, and in these parentheses I want you to declare the file name of the output file that you want to use. Now, that being said, if there's already an output file that has been made that is in the current directory, then of course you just want to enter that file name. Now, if it's in a different directory, you're going to have to specify the full path, and to do that you would say, C for the C drive, colon // users // and you do have to have double backslash when using these strings. And without going too much in depth, because I would really need to put that in a new tutorial, and I will actually make a tutorial about that. But the first backslash when dealing with strings is considered an escape character. So just know that whenever you're specifying these files and you use a backslash, you need to put two of them in order for the first one to be read. So that's how you would do that. But for me, I'm just going to declare a new file, and it's going to be in the current directory, and I'm just going to call it names.txt. Just like that. And if you run this, everything should run fine. It will just return 0, and you know that you don't get any errors. Now, names.txt is going to be the name of our output file that just got created. So if we actually go to open right here, it should have created a names.txt file right here, as you can see, for us, since we just ran the program. So now that the file is created and everything is fine, we can actually start writing to that file. Now, before we do that, it's always good practice to have a branching statement in case something goes wrong with creating that file or finding it. And what I like to do is say if not output file, which means output file, if not output file, it basically means if the output file returns false, meaning that it couldn't be created, then run this code. So that means if the output file names.txt could not be created nor found, then do this, and we'll just output the file could not be found. And then we'll say return -5. And this can be any value. I could say return -7. I could say return 9. I usually put a negative value like -10 or -5. And that way, when we run the program, like we'll run it right now, if it says process returned -5, I know that the file was not found. And you just use a random number like that you can easily associate with an error. And that would definitely be an error. But since process returned 0, we know that names.txt was created. So let's move on and let's actually write to this file. And to do that, let's create a string name equals Zach. And this is going to be a fairly easy example. And whenever we make our practical program at the end of this section, you'll see a more in-depth way of looking at file output. But for now, I'm just going to show you an easy, in the simplest way I can, how it's performed. So we're going to make string name equals Zach. And now we're just going to write that name to a file. And to do that, we use our output stream name, and the handle on that is called output file. And then to write to it, you use the output operators as so, less than, just like if we were doing cout to output to the screen, we use these less than. Instead, we're going to do output file, which is our output stream up here, and we're using output file. That's the handle name, you should say. So output file less than name, and then return 0. And if we run that, everything should run fine with no errors. And if we open, let's just open names.txt real quick. We're going to open it right here, and you can see Zach was written to this file.